In this lesson, we're going to start learning about polynomials and the portions of what a polynomial is. We're going to start by going over a couple of concepts that you have previously learned about, but we're just going to review these skills because we will be using them within operations with polynomials. So the first thing we're going to do is just simplify expressions. So what that means is we're just going to combine our like terms and make it a simpler looking expression. It's called an expression because there's no equal sign. If it had an equal sign, then it would be called an equation. So what we're going to do is just combine our like terms. So I like to underline my like terms. So I have these x's in our first example. Then I underline twice my constants, my just regular numbers. So I have a 5x and a negative 2x. Well, that makes 3x. And then a 7 and a negative 3 makes a positive 4. And that's your answer for this first expression. The second one, I see parentheses, which means that we need to distribute our negative 7 and multiply it to that y and that negative 2. So negative 7 times y is negative 7y. A negative 7 times a negative 2 is a positive 14. And then I bring down that positive 3y. Now I get to underline and combine my like terms. I just have my y's to combine, and a negative 7 with a positive 3 is a negative 4y. And then we drop down that 14, and that's our answer. So go ahead and try the next 6 on your own. Pause the video, double check when you come back to see that your answers are correct. All right, so here are your answers that you should have. Now, you also can put negative 1n or negative 1z. That means the same thing. So just make sure that they're negatives and make sure your answers are correct. Now, another skill that we're going to talk about are greatest common factors, GCFs. So basically, you're going to be given a bunch of pairs of numbers, and we have to find out what the greatest factor that they have in common is. Now, factors are numbers that multiply together to create that specific number. So if we're talking about 50 in our first example, we have 1 and 50. You have 10 and 5. We have 2 and 25. And that's it. So now we're going to move over to 75. And what we have here is, again, 1 and 75. We have 5 and 15. We have 3 and 25. So now we have all of our factors written. We have to find now the greatest common factor. Well, the common factor we have is we have 1s, we have 5s, and we have 25s. Now, obviously, we choose the greatest common factor. So our GCF, our greatest common factor is 25. We can divide both numbers by 25, and that's what we would want. So now we have 30 and 42. So for 30, we're going to go ahead and start dividing it out. We have 1 times 30 is 30. We have 3 times 10. We have 2 times 15. We have 5 times 6. Now we're going to go to 42. We have 1 and 42. We have 2 and 21. We have 3 and 14. And we have 6 and 7. So now we're going to look at our common factors. So we, of course, have 1. That's pretty simple. We have 2. We have 3. And then we also have 6. Now the greatest common factor is that greatest number that we have. And our greatest common factor is 6. Go ahead and try the next 4 on your own and check back to see your answers. All right, so these are the greatest common factors that I found. If you want to take a minute and pause the video to look at the factors that I found versus yours, to just double check to see that you got the right answers as well. And make sure you just circle the one that's the largest and write it down. Now we're going to get into the actual lessons of polynomials. So a monomial is a number or a variable or a product of a number, and it just is one part. So if you're thinking about the what the word mono means, it means one. So you're going to have one part together. So these are some examples of monomials. These are all going to be stuck together as one. You're just multiplying, okay? Or it could just be a regular number like -4. Now, non-examples are when we're talking about different kinds of exponents. So you have to have whole exponents, not decimals or fractions. Then you also have to have numbers in denominator. So monomials cannot have variables in the denominator. So that doesn't work. And also monomials cannot have variables in the exponents as well. Okay, so honestly, the things that we rarely see in math anyway will not count as monomials. So let's kind of also talk about the degree of monomials. So the degree is the sum of the exponents, okay? Now, it's the sum of the variables, the exponents of the variables. So when we have just a regular number, as you'll see, we don't count that exponent of the variable. So let's get right into examples so you guys can see what I'm talking about. So in this first example, it says to find the degree of each monomial. So we only have to find the sum of the variables. Okay, so 5 is not a variable. We don't even consider it. So we only have 2. So the degree is 2, the exponent for our variable. So that's the degree for that first monomial. The second one, we have 1/2, negative 1/2. That's not a variable. We do not care. X has a 1 as an exponent if it's not written, and then y is 3. So we just do 1 plus 3. So our degree of this monomial is 4. On our third one, as I stated earlier, you cannot have, it's only the sum of the variable exponents. 3 is not a variable, so the degree of this negative 3 is just 0 for this monomial. Go ahead and try the next 3 on your own. Check back and see if your answers are correct. So these are the answers you should have received. We're only talking about our variables, so you can really cancel out the numbers that we're given, and you're just thinking about your variables. So we have x to the 4th, so that's 4. We add our 3 and our 2 to the second problem, becomes 5. And then y, if it's not written, the exponent is 1, and that's your degree. Now, aside from monomials, we're going to talk about different kinds of polynomials. So this is when things are going to be added or subtracted. So different monomials are going to be added or subtracted. And based on how many times that happens is what kind of polynomial you have. So if there are 2 terms, then we have a binomial. Bi means 2. If we have 3 terms added together, then it's a trinomial because tri means 3. And that's what we're going to talk about. Now, the degree of an actual polynomial this time, not monomial, it's the greatest degree of the terms, okay? Now, we also have to talk about the fact that it has to be in standard form. In standard form, that's when the exponents decrease from left to right of the terms. And so we're going to kind of classify and do all of that in these examples to kind of put polynomial classification all together. So let's go right into our example. So it says write each polynomial in standard form, then identify the degree, and then classify it. So this first one, it's just one term. So in standard form, it's the same thing. We just write it again, negative 3 z to the 4th. The degree is the greatest degree of the terms, and so our degree is 4 since that's the only degree we have. And since there's only one term, the type of polynomial we have is a monomial. So this one was kind of basic. We've already talked about monomials. The next one is where things come into play. So we have 3 different terms here. So I'm going to jump right ahead. And the type of polynomial this is a trinomial. We have to put it into standard form. So in standard form, we have 5x squared minus x plus 4 because of the degrees. We have 2 right here. That's the degree. And it's going to decrease from left to right. So this x has a 1, and then the 4 is a 0 degree, as we've talked about earlier. Now, to find out the degree of the actual polynomial, it's the greatest degree, which is 2. And that's our answer. Now we're going to move on to more problems of this on the next side of your paper. And let's do it again. So for this next one, in standard form, we're going to put q to the 5th first because that's the greatest degree, plus 8q. Again, the greatest degree was 5, so the degree of this polynomial is 5. And the type, since it has 2 terms, it is a binomial. I want you guys to try to do the next 3 on your own and check back to see if your answers are correct. All right, so these are the answers you should have received. You always put the highest degree in front. So make sure you bring that negative sign with you. The degree of the polynomial, again, is the highest or the greatest degree you're given. And then the type is pretty simple. If there's 2 terms, it's a binomial. 3, it's a trinomial. And then if there's just 1, it's a monomial. So think about what the words mean. So now we're going to connect all of this to a real-life example. We're given a polynomial. That looks kind of crazy, I know, but they're going to say what all of the parts mean, which is going to be very helpful. So this is talking about the height of an object. So we have V0, which is the initial vertical velocity, and S0 is the initial height of an object, just so that we know. T also means time. So what they're saying is that we need to write a polynomial that represents the height of the baseball. So the baseball picture is not on your paper, but it's here on the video. And they want to have us write a polynomial that represents the height. So basically we have to take all of the pieces and plug them into the problem. So we're given our original height, okay, and we're given our original velocity. So we're going to insert it. So I have negative 16t squared that stays the same, plus our velocity, which is 30t, plus our initial height, which is 4. And that's all we had to do. We just had to plug it in. Now we're going to plug something else in. It says, what is the height of the baseball after 1 second? Well, all you have to do is plug in 1 for your t. So let's go ahead and do that. Negative 16 times 1 squared plus 30 times 1 plus 4. So now let's go ahead and solve it and simplify. Well, 1 squared is 1. So negative 16 times 1 is negative 16. Plus 30 times 1, which is 30, plus 4. So now we're going to go ahead and add all of it together. So negative 16 plus 30 is 14, and then plus 4 is 18. So the height of the baseball after 1 second is 18 feet in the air. Now we're going to kind of alter things a little bit. It says in the last problem, pretend the initial height is now 5 feet instead of 4. Now, what is the height after 2 seconds? So you're going to plug in that initial height for S0 and then 2 seconds for t. So first off, our entire polynomial is going to be negative 16t squared plus 30t because our velocity is the same. Now instead of plus 4, we're going to have plus 5. So that's what we're doing. Now we're going to plug in 2 for t. So it's negative 16 times 2 squared plus 30 times 2 plus 5. So let's go ahead and solve it. We have negative 16 times 4 plus 60. I'm kind of going ahead, plus 5. So we're going to go ahead and totally solve it. So we have negative 16 times 4. I'm going to kind of move this over here, which is negative 64 plus 60 plus 5. When I start adding using, order of operations, we are given a negative 4 plus 5. Our answer is 1 foot. So if she was 5 feet tall and tossed the baseball up in the air, after 2 seconds, it's going to be 1 foot from the ground.